Today we're going to talk about how to solve radical equations. Okay, so we're going to first talk about the steps to solve a radical equation. The first step is to isolate the radical on one side of the equation if necessary. The second step is to raise each side of the equation to the same power and index to eliminate the radical. The third step then is to solve for the variable. And the final step is to check for extraneous solutions. Okay, so let's go ahead and do a few examples here. We have the square root of 5x minus 9 equals 11. So following our steps, the radical is already isolated. And now we need to go ahead and raise each side of the equation to the same power so that we can eliminate the square root. Now we can go ahead and simplify. And now this becomes a simpler problem that we could all solve. So now we have our solution that x equals 26, but we still need to check to make sure that we don't have any extraneous solutions. So we'll go ahead and check. So yes, the square root of 121 is 11, and we have not created any solutions that would not be viable in the original equation. All right, let's continue on, do a few more examples here. We have the cube root of 2x plus 7 equals 3. So we'll go ahead and raise each side of this to a power. We can now simplify, eliminating the cube root. And now use our algebra skills to solve. We have x equals 10, and now we will go ahead and plug that back into the original equation to check whether we've created any solutions that are not viable. And again, this works out for us. There are no extra or extraneous solutions. Okay, a couple more examples here for us. In this case, we have the square root of x plus 1 plus 2, and that needs to equal 4. Our first step was to isolate the radical on one side, if necessary. In this case, it is necessary. So we need to subtract that 2 from both sides. We now have the square root of x plus 1 equals 2. And now we can go ahead and raise this to the same power on each side to eliminate that square root. We have our solution, that x equals 3. We'll go ahead now and check. And again, this does in fact work. We have no extra solutions here. Let's do one more example. We have 4 times the cube root of 2x plus 11 minus 2 equals 10. So again, we need to first isolate the radical on one side of the equation. Continuing the process of isolating the radical, we're now prepared to raise each side of this to the same power to eliminate the cube root. We can now simplify. Oh, my apologies. I was writing the wrong number there. It's 11. And now we have an algebra problem, a fairly simple one. And we have our solution, that x equals 8. So now we need to take a moment and go ahead and check to make sure our solution is viable. And we can see here that we again get a valid true equation, and so our solution is valid. Next time, we'll take a look at some more examples, specifically with extraneous solutions, as well as more complex exponents, and then finally with some radicals on both sides of the equations. So look forward to that.